There's no quiz today.
Come on, Mr. Davis, I studied.
You studied so you can freaking learn them.
Yeah, but I wanted to be rewarded for my studying.
You will when we do the problems and you know what it is.
Does that mean it's tomorrow?
Yes.
So does that mean that there's a quiz Monday or Tuesday, in which case there will be a quiz tomorrow?
Could be both. I could decide in 20 minutes and change my mind and I'm going to give you one.
Okay.
I could decide tomorrow. I could not. I could decide in next week sometime. Who knows? It's your job to know that. What's the integral of sec tan? Plus c, right? What's the integral of x to the negative first? Plus c. What's the integral of cosine? Positive sine. Plus c. The sine cosine is probably the trickiest one. Just because like it gets confusing. But yeah, there's no quiz today. We're actually not going to be to the trig part of reverse chain rule today. But we will tomorrow, so take that for whatever you like to take it for. Alright, I'm going to do reverse chain rule, and I'm going to teach it to you two ways. I'm just going to tell you up front, I'm teaching it two ways. I used to teach it like my way, and my way worked, and I got people good scores on the AP test, they understood it, that was all fine, and then people would come back from college and be like, your way was cool, but like they teach it different in college, so we think it'd be good if you like showed your students that way also, and then at least they have a choice. So I'm going to show you my way, which probably won't be how college professors talk about it, and then I'll show you the college professor way, and then you can kind of choose whatever makes more sense to you. Alright, so let's start off by saying reverse chain rule. So going back to chain rule, so let's say remember chain rule. Chain rule said if I have f of g of x, then what's the derivative? Good. So f, you take the derivative of the big guy, right? F prime, we leave the little guy alone. Remember, leave Mr. Packard alone. And then we take the derivative of that little guy, of Packard. So, when I brought this up to you, so here, let's do an example. Just reviewing regular chain rule. Let's say like 3x squared plus 7x to the 4th. You take, so what's your big guy in this case? The 4. So you're going to take the derivative of the big guy, which in this case is a power, so you bring it down, reduce the power by 1. What do you do with the little guy? Leave Packard alone, and then you multiply by the derivative of the inside, right? So when I taught this to you, this like times g prime of x, or this like 6x plus 7, it kind of came out of nowhere, right? So I was like, oh, you take the derivative of this, you leave this alone, and then you're multiplying by the derivative of g, because you haven't really done that yet. But basically, we had this, and I was like, oh, you got to multiply by g prime. So there's just g prime that just came out of nowhere. None of you even like blinked, asked a question, how does that work, anything. Now that we're going backwards, I'm going to be starting with this, and I'm going to go up to that. So what's going to happen to the g prime? It's going to disappear. But for some reason, that freaks people out. When I made it appear out of thin air, everyone was like, oh, that's cool. No problem. When I make it disappear, people are like, what the hell is going on? But it's the same thing. So the same reason I have to multiply it on the derivative is this, if you just reverse that process, it kind of gets like sucked back in when you do the integral. So if I were to integrate, let's say 4x times 2x squared plus 7 to the 5th. So is going to be like my talk through, like my lingo, my big guy, little guy type of thing. We'll do a couple of those, and then I'll show you, it's called U-substitution, which is more the way like a college math class would teach it. So if you're going on in math past, I'd say CALC 2, you should probably be doing the U-substitution way. You don't have to do that every problem, but you should understand that way. If you're not, this way works. It's just going to be a little bit different when a college professor is not saying like, take the derivative of Mr. Packard. It's not going to happen in college. So I need to look at this and identify 3 things. The big guy. So there's a big, a little, and a little prime. So basically your big guy is your F. Your little guy is your G. And the little prime is G prime. So in this problem here, what's the big guy? The 5th power. That's like the most outside dominant function. Does that make sense? What's your little guy? 2x squared plus 7. And then isn't that the derivative of the little guy? Yes. So it matches. Now what's going to happen as we start going forward is that's not going to match. We'll have to start kind of tweaking things so it does. Which we'll get to eventually too. So here, if I'm going to do this problem, what I'm going to tell you is integrate the big guy. This is my phrasing. Integrate the big guy. You still leave the little guy alone. Derivative of little guy disappears. And that's for the same reason that when I took the derivative, I had to multiply by the derivative of the little guy. So, my big guy is the 5th power, right? Yeah, got it. Bigger.
The little guy and the little guy prime are the same, right? They're both 2x squared plus 7.
No, the little guy is 2x squared plus 7. So if I just said to you, okay, that's the little guy, and I asked you what's the derivative of that little guy, what would you say? And that derivative needs to be, that's what's out here. That's the 4x, that's the derivative of the little guy. That's what's going to disappear. So, big guy's a power. How do you integrate powers? Add 1, multiply by the reciprocal, right? So let's do that. So we're going to add 1, multiply by the reciprocal. What do you do with the little guy?
Just break it down.
Leave it alone. And what happens to the derivative of the little guy? It vanishes. What's the only thing I still need here? Let's see. So, we get to this, and people are, you may or may not be convinced at this point, but if you're not convinced, because these look a lot different. I mean, this has like an extra thing there, and this doesn't have that. So, how could we check it? Take the derivative of this, and if we're right, we should get that. So let's do that. If I take the derivative of that, bring down the 6 times 1/6, what's that? Leave the little guy alone, reduce the power by 1, and then what would you multiply by? Multiply by 4x. So does that make some sense what's going on there? Alright. What?
When it doesn't match, does it still just disappear?
Let's hold off on that. Well, we just adjust it, and then it disappeared. Let's just hold off on it. I mean, we're getting there in like 10 minutes. It's not like it's 2 weeks from now. Sort of. Let's 10 minutes. Chill. It's not like I'm saying we're learning this in April. We'll be soon. So then, you should be able to tell me the integral of that. That's the general form. So anything in that form, this is like the chain rule, the reverse chain rule. If I were to put it in like math lingo. So, what's the big guy in this problem? Not F. F prime. So our first job is to integrate the big guy. So what's the integral of F prime? F. What do we do with the little guy? Leave him alone. And then the derivative of the little guy vanishes. So this is reverse chain. I don't think most people think about it that way. Even in college, like that's not really the way. Maybe somewhat. That's just like a formal definition, though. Try this one. I mean, I can't. There's not a wide variety of questions I can give you at this point, so that's pretty similar to the last one, but that's okay.
So can you just do times dx because it's all being multiplied together, so you don't have to put parentheses?
Correct. It's all one term. Why don't you sit up here?
Because you're intimidating.
Better? How's your drive here this morning, Kyle? Safe?
You didn't know we couldn't see.
Yeah, really.
You were rushing.
This is why we all root for you not to be here. Alright, what's the big guy? -3, so we integrate, and it's a power, right? So the way we integrate powers, add 1 to the power, multiply by the reciprocal of the new power. The little guy stays just like it is, and what happens to the derivative of the little guy?
He evaporates.
Vanishes, and that would be your answer. And if you're not convinced, take the derivative of that, and it will match.
So none of the negatives matter, like you don't have to like move it around or anything.
What
Put it on bottom.
What?
Powers.
Like you don't have to put it on bottom or anything.
Oh, I got you. I'm not worried about that right now. I'm just trying to get the process down.
Okay.
If I ask you to simplify it without negative, I mean, you could do it, right? Just
You just put them on the bottom.
yeah, if I said no negative exponents, you could just throw that to the bottom, right?
Yeah.
How many had this answer before I went through it? Okay. Questions on the process, like with this kind of instruction, I guess. So I'm going to show you the U-substitution, and I'm going to tell you it's harder. It's more work, but there's a reason they use it in college is because when you get harder problems, it's better. I'm going to do the exact same problem.
Yeah, no, I should have put it down.
Oh, it's called U-substitution. So pretend up there I said U-substitution. Forgot you guys like labels. Sorry. I like what? I know, you'll freak out about titles. It's a U, but in stats there's mu's and I get like mixed up. It's just a
like
U.
That's what I thought it was at first, but I was wondering why you.
Well, mu is this, and
Yeah.
I tried to write a U, and I'm not smart enough to really remember the difference.
U is a Greek letter. U is.
Okay, so what you're gonna do here is set U equal to the little guy. You want U to equal the little guy. So in this problem, what's the little guy? 3x squared plus 10. Then, we're going to take the derivative of that. So technically, the derivative would be the derivative of U with respect to x, because those are the two variables that we're working with. So if I take the derivative of this function is called U, the variable in there is x. What's the derivative of 3x squared plus 10? 6x. My job now is to solve for du. I want du by itself. So I'd multiply both sides by dx, and I would just end up with du equals 6x times dx. The more you do of these, you will most likely skip this step every time. And you'll just like put the dx at the end, and that's fine. Now, we want to rewrite the original problem with u's in it instead of x's. It's called U-substitution, so we're going to turn the problem into u's, make it easier, do the problem, put it back into x's. Alright, so if I rewrite this problem, doesn't that just say u to the negative third now? Since u is equal to 3x squared plus 10, isn't that just u to the negative third?
You're just making the 6x disappear.
I didn't get to it yet.
Okay. Yeah.
What am I going to put in place of 6x times dx?
Oh my gosh, wow.
du.
I'm very, that's insane.
Okay.
U times D.
I got mine's getting blown and I got people confused.
Times D.
I was only confused with this.
What goes in place of 3x squared plus 10?
U.
U, because I declared that to be true. I said u equals 3x squared plus 10. Then, I can't replace the negative 3, like that's just part of the problem. But, what goes in place of 6x times dx? du. So now that's your problem. Which is, you know, in theory, a lot easier problem than what we started with. So we're transforming it to an easier problem. We're going to do it, and then we're going to put the x's back. So now it's just, there's no chain rule, there's no disappearing, it's just, what is the integral of u to the third? Well, I'm going to add 1 to the power, which would make it negative 2. I'm going to multiply by the reciprocal, which makes it negative 1/2. And the du, this represents like the tiny width of those rectangles, and that just disappears just like the dx does. So that doesn't really, that's not really relevant. And I just need a plus c. And this can't be your answer though, because the question was given to me with x's in it, so I have to give my answer with x's in it. So what do I put here in place of that u? 3x squared plus 10, the same thing that I substituted the other direction just a couple minutes ago. So, I mean, we get the same answer, right? Yeah, so that's the thing. Like, if I just give you a basic problem, I probably wouldn't use this method. But you need to know this method, because when you get a harder problem, my, like, big guy, little guy method falls apart at some point. It's like, okay, now I got a big guy, a little guy, a tiny guy, and then his kid, and it's all, like, it gets... So, like, it can work, but you lose track of what's going on. So ideally, you'll know both. And you can look at a problem and be like, that's a fairly straightforward one. I can just think big guy, little guy, and knock it out. Okay, it's tougher, or I'm stuck. Now I'm going to go to this U method. Yeah.
Aren't you supposed to do normal chain rule with U-substitution too? At least that's how I learned.
Forward?
Yeah.
Yeah, you could.
Normal.
Yeah. That's not as, like, I don't know, important and harder problem. Yeah. That's how you learned it, though?
Yeah.
So let's try. Are there any questions on, or any other questions on this one, or just in general, like, what's happening here? So you can see, like, okay, e to the 3x times 3 times cosine of e to the 3x times, we're not doing this problem right yet, but we will tomorrow. And if you don't know how to integrate e and cosine and all that stuff, you're dead, you know? So this is why you have to know all that stuff. Because now you got to be able to do the reverse chain rule, know the process, and you have to integrate those. So that's why I'm like making you memorize. All right, let's go back to like a normal, not trig one yet. Let's say x squared times 1/3 x to the third. Bye, Mr. Shin. Thanks for stopping by.
Thank you for the nightmares. I had this exact class 20 years ago.
It was much
It was not AP.
poorer taught
We were all
back in those days. You guys know I had Mr. Shin in class?
I took Mr. Davis' first calculus class.
Yep.
Is that a minus one?
So
She said it's not -4.
Yeah, this much. You don't want to know the difference? 17 years ago, we would have had a 30-minute tangent conversation. Now the class is focused on this. It's outstanding. You know the good one. Thank you.
Yeah, he walked in a while.
Wait, like a student?
He's in my class, yeah.
That's
in your
sweet.
first calculus
That's
class.
weird. Like,
First
think of you guys
calculus
as like the
class.
same
Your
age.
student is not your boss.
Right.
Yeah.
How does that
That's
feel?
weird.
How
That
does
is
that
weird.
feel?
I don't want his job, so I don't give two crap. I mean, I don't care. He does a good job. I'm happy.
Was he a good student?
Does it ever feel weird though? It's like a reverse.
I mean, a little at first, but not
A little what?
weird. He was really smart. He never shut his mouth.
So he was like me.
Kind of reminds me, yeah.
Oh. So I'm gonna become your boss one day.
No, but he was You guys are much more polite than he was. I'll say it that way.
Did he do his homework?
Some,
So
not all, but some. Okay. Anyway,
asking Siri how to do the problem.
did you ask Siri how to do that? Anyway, what is, so if I'm going to do the U-substitution way, because we're trying to kind of wrap our minds around two methods here. What would I set U equal to?
1/3 x cubed minus
The little guy.
4.
Yep, you're always setting it equal to the little guy. And then you take the derivative of that. So what's the derivative of 1/3 x to the third? X squared. And I'm just going to throw a dx in the back. So I did that in 2 steps last time, where I went du over dx equals x squared, and then I multiplied both sides by dx. You don't need that step, but I'd like you to understand like why it's happening, I guess. So these are your 2 things. Now let's rewrite it. So if I rewrite the integral, it would be u to the 5th times du. You guys see where I'm getting that from? So instead of x squared times dx, I put du. Instead of that, I put u, and then the 5th power is still there. See that? And it's just, now there's no chain rule. Like, the point is, it makes the problem easier, but it's kind of a pain in the butt to make the problem easier, so you only really use it if you need to. So add 1 to the power, multiply by the reciprocal, toss a plus c on there, then plug your x's back in. So what was u in the first place? It was 1/3 x to the third minus 4. Now I can talk through that problem using big guy, little guy, like one step. It's a lot faster that way. So I would look at, like, if I got that problem presented to me, do it. I wouldn't use U-substitution. I would think through and go, okay, that's my little guy, that's my big guy. The derivative of this little guy is there, and so we're okay. I'm going to integrate the big guy, add 1 to the power, multiply by the reciprocal. Derivative of the little guy disappears. And so I can get to it either way. I want you to understand both. Yeah.
So, I don't know how to explain it. Maybe I should just show you it, but
Where are you looking?
so the du
Yeah.
is it should be 3 x squared.
Bring down the 3 times 1/3 of your 1. du is the derivative of this. Are you having vision problems and you thought that was a 2?
Yeah.
You just sit in the front. Wait, what if you sat here?
You gotta be like my mom. You gotta go like 2 inches from it.
You can look at those.
No, it's
It's
not.
not all good. It's what we have. It's like 5. Alright. I want you to
My
no.
eyesight's really good.
Yeah, it's solid. I would like you to try to do that problem kind of both ways. Like, can you reason through it with like the reverse chain rule, big guy, little guy approach? And then can you do U-substitution? Before you drop it on the floor.
I put the other one in my backpack, so.
So first we write it, right? So it's the 1/2 power. So that's your first step, like either method you're using. That was like a mic drop. You knock them out, both methods?
Yeah. The first one's just a lot faster.
It's way faster. But like that problem I showed you with the cosine and stuff, that's when like the U-substitution is valuable. I understand that U-substitution is not the efficient way to do that problem. I wouldn't use it either. Just kind of trust me, you will get to a point where U-substitution is more beneficial.
And in some ways, you're already thinking of U-substitution, like you just instead
Yeah,
of
the thought
thinking
process
U,
is the same.
it's just you're thinking big
Yeah.
guy, little guy.
Yeah.
Will we get to that point in this class or like later in calculus?
Depends on the person. So like everyone has a different ability to kind of see things in their head, you know. Some people will get through this whole class using and never touch it. But then they might go to college and be like, well, wait, what is the, you know, part of it is you're just preparing for college too. And there's some people that might be using U-substitution already because they have trouble seeing it like in this form. So it just depends on like your level of. Okay, so if I'm like reasoning through it, I'm just going, okay, big guy, little guy, derivative of little guy. So I'm going to integrate the big guy first. So that's 3/2. I multiply by the reciprocal of that. I leave the little guy alone. Derivative of the little guy disappears, and that's my answer. How many have that answer first of all? Okay. So yeah, that's certainly a faster way, right? Over here, I'm going u equals 3x squared minus 4. du equals 6x times dx. So then there's my 6x and dx. So when I rewrite it, it becomes u to the 1/2 times du. So 2/3 u to the 3/2 plus c. And then plug in the x's back in place. And you end up at the same spot, just a little bit longer journey to get there. How many of you were able to get there using the U-substitution method? Okay. Questions there before I move on to like, okay, what if it's not balanced? You got what? Oh, right, like accidentally. Alright, so let's say this. Let's say the integral of x squared times 4x to the 3rd minus 1 to the 5th times dx. And again, I'm going to talk through this two ways. I'll do like the big guy, little guy first, and then I'll do U-substitution. So the difference here, or the issue, is that this is my little guy, right? Do you agree with that?
Yeah.
What's the derivative of the little guy?
8x squared.
12x squared.
Same thing.
So I don't have that here. And the problem, every problem I showed you so far, it was just perfect. Like whatever the derivative was there of the little guy was here. It was just set up that way. Now, this is supposed to be 12x squared, and it's not. So, we are allowed to multiply by a constant if we want to, as long as we multiply by the opposite of that constant on the outside of the integral. So, I'm going to make that, I'm just going to say, okay, yeah, it's 12. I'm allowed to do that as long as, so I just multiply the whole problem by 12, right? What I'm going to do to compensate for that is I'm going to multiply the whole problem by 1/12. So what did I really multiply by now? 1. So I didn't change anything. I just kind of rewrote it so it fits my needs. So I put a 12 there. So now that I've done that, this is the derivative of your little guy, and what is going to happen always to the derivative of the little guy. So that is going to disappear. I had to put that 12 there to make it so that would work, but it's going to disappear. And then I balanced that. So that 12, like really that 12 is going to disappear. So is there any, you have to write it, but does that 12 actually mean anything? It's going to disappear anyway, so it kind of is irrelevant. But the point of the 12 is to know what to balance it out with. That 1/12 matters. That's going to go into our answer. So, now I would integrate the big guy. So I add 1 to the power, multiply by the reciprocal of the power, But there was a 1/12 out there. That still has to be taken into account. Leave your little guy alone. You got your plus C, so this would be like 1/72. Questions on that one, where I'm going to have to like kind of rebalance things. Should I do another one with that method, or should I do that one in U-substitution? Do that one U-substitution? Alright. So it was the integral of x squared times 4x. Okay. What would U be equal to? Little guy, right? Yep. 4x to the third minus 1. Du would equal 12x squared and then times dx. Agree? So the issue here is 12x squared times dx it's not in the equation. It doesn't work. So what could I do to this to make it so it does match up with the equation? Multiply it by what? By 1/12. Then I would get 1/12 du, because I'd multiply both sides by 1/12, because I'm fair, equals x squared times dx. That's the important step in this. It's right there. So I'm just going to say it again. Du was equal to 12x squared times dx. That was just taking the derivative of this. But 12x squared times dx isn't what's up here. What's up here is x squared times dx. So basically I'm saying, how do I go from 12x squared to x squared? And you multiply by 1/12. So we multiply both sides by 1/12. And now what do I replace the x squared dx with when I go to rewrite it? 1/12 du. And I'm just splitting them up because I know that u to the fifth is going to go in the middle. What can I go over again there?
Do you have to put the du of
Of which?
the equation right there?
Yes.
Has to be the
I'm sorry, no. It could be, so you went like 1/12 du, u to the fifth?
yeah.
That's fine. That's fine. You put it in the middle.
And then I get rid of it still. I just
Yeah, just be careful if it's like 2 or 3 terms that you put parentheses in the right spots to make sure. So then, integrate this. Okay, we'll add 1 to the power. Multiply by the reciprocal, so what's 1/6 times 1/12? 1/72. And then you put your x's back in. When we get to the same spot, it was just slower and probably more confusing, which is why I have my other method, but also this is a legit method you should know going forward, so I'm trying to show you both. Yeah?
Okay, so in regards to the U-sub method that you just did, what if you did like in your previous one with the 1/12 up in like the very beginning and put the x squared times 12 and then carry that through? That still work or would that fail?
Let me rewrite the problem, then ask that again. I'm not sure what you're saying. Say it again.
If you put your 1/12 out in front of the summation, or not summation,
It is the summation, really. Integral sign, yeah.
and then put your 12 in front of the x squared, and then you did the U-sub, would it work from there?
Yes. So he's saying, I'm going to do u sub, I'm just going to balance it before I do it. I actually like that. So now we got u equals 4x to the third minus 1. Du equals 12x squared times dx, and we're good to go. We already balanced it. Yeah, that's cool. Well, the 1/12 will come down now. So now it'd be 1/12 integral of u to the fifth times du, which is the exact same thing that we ended up with here before I wrote that 1/6. Doesn't matter. You're gonna multiply by it either way. Yeah, I like that verse. Just balance it first, then go. It's cool. So I've taught this U-substitution method for probably like 5 years now, and no one's ever said that. Maybe people didn't tell me, but that's cool. Other questions before I just keep going, I guess? do this one, and you have to use U-substitution. I'm trying to work here. Keep it down, please. Rude. What'd you say?
My mom punches people when she sneezes.
She just starts flailing about like, achoo!
I get like if you're in the car and you're in the next seat,
You're in
she
danger.
sneezes, she smacks you in the face really hard.
Good to go or not yet?
Not yet.
Okay. Just, it's hard to tell. We alright? Or not yet?
I'm good, but
No worries. Alright, let's go. So, we can think about it two ways. You could actually balance it out first, like Merch was saying. So this is your little guy, right? What's the derivative of that? 2x, and we have 4x, so we can tell right now it's not going to match. How many balance it out first? How many balance it out second? It's like half and half. I'm going to balance it out first just because I haven't done one that way yet, so just show you like a different option. So, what is this supposed to be? What do I want that to be? A 2x. So what do I need to multiply in order to make that happen? 1/2. And then, because I multiply the inside by 1/2, the only way that works is if I multiply the outside by 2. Now, at this point, you can basically just cross that out. Like, we know that's just going to go away eventually. I probably should have rewritten this, but I'm being a little lazy, and let's just make that to the 1/2. Now, what's your big guy? Oh, I said U-substitution, didn't I? So u equals x squared minus 1. What's du? Times dx. And then if I rewrite my integral, it would be 2 times the integral of u to the 1/2 times du. And if you balance it out now instead of earlier, your 2 would just be on the inside, but that doesn't matter. Like 2 on the inside, 2 on the outside are the same idea. And then I would add 1 to the power, multiply by the reciprocal, so 2/3 times that 2 that's already out there is 4/3. Then you're going to put the x squared minus 1 back in. What? And that's your answer. How many have that answer? What did you say?
I said food in the bar. Wonderful. Sure.
Thank you.
You're welcome.
How many have that answer? Questions? Go through this. Where'd this come from? I did this different. Anything? How's this seem? All the way good, all the way bad, diagonal.
Really good.
Okay. Alright, we'll see. So, like half of these, you have to balance.